We focus on environmental technology research, sustainability research, and transportation. We look at better ways to make sustainable transportation fuels and everyday materials from waste plant biomass. This biomass is generated every day by our forestry and agricultural industries, and also we can use specialized non-food crops that can be grown in challenging environments such as industrial hemp and agave. We've taken a fascination to looking at industrial hemp because it was recently decriminalized through the Farm Bill Act to allow American farmers and agricultural experts to look at hemp once more as a sustainable feedstock for textiles as well as green construction materials. This is a sample of one of the first ethanol or alcohol samples we made from wood. Traditionally, as you know, alcohol or ethanol is not made from wood because wood is very difficult to break down. But through our process called the co-solvent-enhanced lignocellulosic fractionation, we were able to break down wood effectively enough so that we can use enzymes and yeast to convert it into ethanol. We believe that using plant biomass to support production of green energy, renewable fuels, green construction materials, bioplastics, and alternative textiles could enable a far more sustainable future industry. Batteries for electric cars use lots of minerals and rare earth metals that need to be mined from the earth using hazardous chemicals and heavy machines that run on petroleum. A significant portion of our electricity is also generated from natural gas or coal. Plant matter, on the other hand, is naturally occurring, and its growth is sustained by our sun and the CO2 that we breathe out. All plant biomass, including non-food residues, contain high-energy carbohydrates, natural polymers, resins, and proteins that can fully support a future bioeconomy and meet our energy demands. My group also looks at using bleeding-edge techniques such as supercomputing and computer modeling to aid our laboratory experiments so that we can speed up our discovery process for better and cheaper ways to intercept the components in plant biomass. What we can do is we can actually create oils directly from the plant in a matter of 30 minutes or less. This is an extremely efficient way to break down plant material by using a renewable co-solvent called tetrahydrofuran. We use this in combination with water to effectively break down plant matter within minutes. The idea for needing technologies to efficiently break down plant matter is because it is the most challenging and expensive step in converting plant biomass into renewable fuels and materials. Using the self technology, we can process all kinds of plant feedstocks, from corn stover to wheat straw to oat hulls, even forestry residues like sawdust from pine, poplar, or maple wood.
According to research done by the U.S. Department of Energy, the U.S. alone is capable of generating up to 1 billion tons of plant biomass each year. So this is a 1 liter PAR reactor that we use to run self-pretreatment reactions at the 1 liter scale. We have multiple valves we can add additional process steps to agitate the material that's inside the reaction. We've done thousands of reactions with this and it's held up really well. One of our most important objectives is to find better ways to efficiently break down plant matter and to soften its naturally resilient structure.
Here you will see a pilot reactor that was built to scale up the self process from the laboratory scale to something that can be demonstrated on the field. We use a steam boiler to deliver steam to heat the jacketed reactor, and inside contains the biomass which we feed and the ingredients that we use for the self process. Then we can take those components as chemical building blocks to convert them into liquid fuels or sustainable materials into 3 major components. Lignin is an excellent precursor to bioplastics, whereas cellulose and hemicellulose mostly contain carbohydrates, which are good for fiber-based materials or as key ingredients for the fermentation of ethanol.
We can gain access to many different useful chemical components within the plant. These plant components, such as carbohydrates, fibers, lignin, and natural resins, then go to serve as sustainable building blocks for producing renewable fuels and materials. We try to develop ways to harness the plant's rich resources without causing significant damage to the components, and we do so without using environmentally harmful chemicals.